and research with deep expertise in EVM, Web3, and zero knowledge technologies. With over 16 years in development, including 7 years working with Solidity on EVM, and 6 years immersed in the world of layers 2s, ZK applications, and privacy ecosystems like Starknet, AZ Tech, Mina, and Alio. Lauri has contributed immensely to Web3 space, from building complex protocols around staking and stablecoins to authoring insightful research articles and ZK apps. His work is both technical and visionary. He is also a top 10 contributor on Ethereum Stack Exchange, helping developers around the world navigate the ever-evolving Web3 landscape. We are thrilled to have with her, we are thrilled to have him here with us today. Please join me in welcoming Mr. Laurie.
Thanks. So, should I just start?
Yes, Lauri, you can start.
Yeah, let me find the right. Here we go. So, yeah, welcome all to this talk, which is something combining privacy and blockchains and seeing how they combine. So yeah, there was an introduction already, but let me give a short other intro also. So I'm Lauri Peltonen. I've been doing freelance now for a few years, mostly in the Web3 space. I've been doing blockchain developments for some 7 years, mostly for the public blockchains and everything around them. And lately, I've been trying to focus more on the privacy aspects. How can we add more privacy and better privacy in public blockchains? So this talk will obviously be a bit about privacy, what it is, how it works, what can be done with it, what we cannot do, and how it's actually broken somewhat. Should we care? Who should care, and how should we care about it? And why blockchains actually aren't so private, especially, well, at least the public blockchains are obviously not the most private ones. And then something can be done about this situation, but let's see what we can do about it. So there's these two concepts first that I want to make clear. There's privacy and then there's secrecy. They are kind of connected, but the secrecy is a bit like the extreme of privacy. So privacy is all about control. We all have some private data or some private information, but we control who sees it, who gets it, and how is it distributed. So this kind of things are widely accepted. So okay, I don't want to send my email to everyone. I don't want to reveal my password. So I control who sees that stuff. And then at the other extreme is the secrecy, which is a bit like nobody can know what I'm doing. And this is it depends on the context, but sometimes it's a bit questionable. But in this talk, we'll focus more on the privacy, which is just about the control of your data or your information. So you have some personal data or some personal information or something you don't want to reveal, and you want to control who gets it and how. And if you use this kind of any service online, it doesn't have to be anything related to blockchain. So any service online, you should be able to control whether you are anonymous in that service or not. So if you have good privacy, nobody can even see your IP address, or they don't get any information about that it's maybe you who is using that service. And that kind of relates also that if there's proper privacy, you are free from surveillance, so nobody can kind of monitor your actions and see what you're doing there. But this is kind of like theory, and in reality, it's of course quite different. But I like to kind of share it as a spectrum. So it's not like an on-off button. There's always a spectrum of privacy. So sometimes you have better privacy, sometimes a bit less privacy, but there's everything in between also. So if we think of like at the other end there's no privacy and the other end there's like full privacy, there's all kind of stuff between these two ends. But all these choices affect a lot of stuff. For example, like if we have zero privacy in some service we use, so there's no passwords, there's nothing. Everyone just goes in and does whatever. Well, it's very cheap to use this kind of service. It's very cheap to develop it, and it's very handy for us to use it. The user experience is awesome. We just go there and we use it. But then there's also no privacy. But if we start adding privacy features, the more we kind of add privacy, okay, let's add an email verification, let's add password verification, whatever. Okay, next step, we need more privacy. Let's add two-factor authentication, whatever. The more we start adding this kind of privacy stuff, the more expensive it gets to use it. And this is not just about the monetary cost, but it's also about the user experience. Okay, now I have to switch to my email program to go verify my email address, and so on and so on. And it also gets a lot more complicated to develop these kind of systems. So it's always a trade-off. And somewhere along these lines, then you also get this kind of regulatory compliance. Like governments are telling what kind of privacy has to be in what kind of services. And it, of course, depends on the case a lot, and on the country also. So in general, kind of, if we talk about privacy, then people are like, oh yeah, it's for some anonymous hackers on chain who just want to stay private, or bank robbers, like they don't want to reveal anything and they want to control their data, or your money laundering. But that's not the reality. In reality, this is not the privacy at least as it should be. The privacy should be for everyone. So you have your health records or whatever health data. You don't want to share it, obviously. Okay, you should have control over your data. That's privacy. You should have control over your bank account information. Of course, the bank has to see it and some official entities, but you should have control over it. So in reality, privacy should be basically for everyone. It's not just for bank robbers, it's for all of us. But if we think of this kind of a concrete service, something like Instagram, which probably many of you use daily, of course it's leaking a lot of your data. So the moment you log in, or you create your account, they get your email address, they get your IP address, of course. They get your device info. Okay, you're using Android. Okay, you're using desktop and this and this and this kind of machine. All of this data is stored. They get your GPS information. Oh, you're located here and here. Of course, and all of this data is either stored in their own servers and they use it for whatever nasty stuff, advertising at least, or they just sell it to someone else who pays for it. Maybe you're searching for something. All of that gets stored somewhere. All of your photos, you lose all rights to your photos probably with the moment you upload them to Instagram. So they get free photos to use for their whatever uses. And all your behavior. Maybe you log in every Monday, 8 a.m. and all of this information is stored. And it's not just about like this kind of unique services. So it's not just about Instagram. So let's say you have an Instagram account and you have a Facebook account. And in your Instagram account, you go check some cute cat pictures every day. Well, suddenly, somehow, Facebook starts showing you cat food advertisements, for example. So it's all correlated, either inside the same platform, so it's Meta owning both platforms, or maybe they just sell the information somewhere. So this is all the privacy you're leaking, and a lot more is leaking every time you use these free services. But do you care? Like, who cares about this? Should you care? Like, you're already selling your soul. You just want to, like, I don't care. I just want to use the platform. It works. everything is fine. I don't really care. But if you listen to this kind of talks, maybe you start thinking a bit more like about privacy. Like maybe I want to have a bit more privacy. How could I do that? How much would I be willing to pay for it? And this is not just about monetary costs. This is about the user experience. So, I have to verify my email. I have to do this and this. And usually, if we talk about monetary cost, the price you're willing to pay is probably around zero. So are you willing to pay, for example, $1 per month to use more private Instagram? Well, no, you're not. Everything works and you don't care. So if you do kind of zero payment, you get about zero privacy also. Of course, they say that they keep some of your data private. Your password, probably, they will not leak it. They will probably not sell your password. But that's probably around the only thing they will not sell. And I'm here to tell you that you should care. So we all have our secrets, but the secrets go they range from, they vary widely. Maybe you're just wearing clothes. So you woke up today and okay, I want to put some clothes on, and then but you never stop questioning, why do I want to put on some clothes? Well, that's privacy. You don't want everyone to see all your body parts. So this is a very simple example, but then it goes all the way to your bank account information and all that stuff. So you're always used to this certain level of privacy. Of course, you put on clothes when you wake up, but then there's this certain other privacy that you are just not used to. And I say it's because it's so inconvenient to use this kind of other privacy options. So let's say there's a better Instagram, and you don't have to pay anything for it, but it's more private. But it means if it offers better privacy, it means that it's somehow a bit harder to use it. Maybe you have to click 2 more buttons to enter it or something at least. So it's inconvenient, and we just want things to work, and we just don't care. And if we go to the blockchain side, so here's just a random blank transaction from some public blockchain. So there's some addresses, who sent this transaction, to whom was it sent. There's some actions, some data sends, which triggers some actions. There's some value, some fees for the transaction. So this is all pretty basic stuff, and everything is public. So you have addresses, and they are not actually very anonymous. They are kind of pseudo-anonymous. So if usually you have your one user, usually you are tied to this one address. So you use this one address, and the more you use it, the more it can be connected to you. All the transactions are, of course, public, and all the data is public, and basically everything in public blockchains is public. So this is kind of a problem in public blockchains. And there's a million ways how you're tracked in public blockchain in a kind of similar fashion as in your Instagram account. But the things are just different. So every action you take is a transaction. Are you receiving something? Are you sending something? Are you interacting with something somehow? That's stored, and it's stored forever. And nobody can actually remove that data. And if you use different wallets, you have different addresses, and that data can be correlated, maybe use every Monday morning at 8 a.m. And those things can be correlated. At some point, someone will make the connection. Okay, these addresses probably belong to the same person. And every time you use your network connection, your IP is leaked through your wallet. And I don't want to know who's buying those IP addresses. And if you actually want to send some transactions in blockchains, you have to have some assets to pay for the fees. And to get some assets, you probably have to use some centralized exchanges. So you exchange your actual money for some cryptocurrencies. And to do that, you have to go through this kind of know your client procedures, where you basically show your passport, whatever, driver's license, and then they scan it and store in their own servers somewhere. and then they give you access to all the assets. So there's these centralized exchanges. They have your real identity, and they can basically, if needed, they can just give it to anyone who asks for it. So probably some authorities, and so on and so on. There's lots of stuff that's being tracked on chain also. So to get full privacy on chain, we would have all the data should be private, probably encrypted. All the transactions, all the actions, like are you receiving, sending something, are you doing something else? And these wallets shouldn't be linked together. And so basically everything you do on chain, it should be hidden in some way. So that kind of sounds all bad, and like, what's the point of public blockchains if everything is tracked anyway? Should I even use them? Well, yes, you should use. You shouldn't stop using them. But the point to remember is that those are public blockchains and they are not meant for everything. They have their use cases, but you always have to remember that they are not private. There's pretty bad privacy. But because they are public, it actually enables a lot of different use cases that aren't possible otherwise. So they have this kind of like on-chain programs called smart contracts that you can just write the program and send it in a public blockchain, and nobody can take it out, and it's running always. And this enables all sort of like decentralized autonomous organizations, all sort of weird new systems that are just not possible otherwise, and cryptocurrencies, also the different assets that are on chain. Or maybe you can even like use an on-chain decentralized exchange. So you don't have to use the centralized exchange, but you can use something on chain if you want to exchange assets. So there's a lot of different use cases that are actually enabled by being public and transparent blockchain. So if public blockchains are kind of bad, so then what about the private ones? Should I just go that route? And those are basically blockchains that are run by maybe one entity or a few entities, and they control who gets access to the blockchain. They basically control everything. But if you do this kind of thing, you basically lose all the benefits of blockchains. So you lose transparency. They control everything. You lose trustlessness. You have to trust those entities do the right things. You lose censorship resistance. So maybe they can just censor you. They don't broadcast your transactions. They're not reliable. Maybe this one entity goes down, and so the whole blockchain disappears. So these are actually not a good idea. There's still some companies using these, some banks, but I think so far it has been established that private blockchains just are not worth it. So they go back to using databases and whatever, like traditional means. But it's not all hope is still lost. So there are ways how we can make these blockchains to have better privacy. It's possible. So there's two main ways how to do it. Either we create a new blockchain that has all these kind of privacy things inside it already. It's still public blockchain, but it enables all sort of privacy features. Or then we add some privacy features on top of an existing public blockchain. Both are valid approaches, but the first one is a lot more harder because you have to create a totally new blockchain that has all this privacy. But then, even if we do all of this, are you kind of willing to pay more for it? Are you willing to pay higher transaction fees, for example? Probably not. So there's all sort of new privacy technologies that are being used in the blockchain world especially. These are also used outside blockchains, but because blockchains are, well, they're public and they are missing privacy, somehow these new weird technologies are being used especially in the blockchain world. And sometimes I feel like blockchains are kind of like spearheading a lot of new innovation and research in privacy technology. So there's stuff like zero knowledge proofs, which basically means that you have some data and you generate this kind of zero knowledge proof that you have this data, and nobody else sees what the actual data is, but you can just prove that you have this data. So you never send the actual data somewhere. Or fully homomorphic encryption, and you don't have to understand any like what exactly these are. These are just random examples. So, and then there's stuff like co-snarks, like you can have like zero knowledge. These are basically zero knowledge proofs which are calculated by multiple entities. So there's lots of this kind of stuff. So if we have all these technologies, like what's stopping us? Why don't we just implement the privacy features? As we kind of saw like a bit earlier, if we do, all the things get harder to use and they cost more, and you still don't care. There's so many privacy projects around public blockchains that simply go down. They fail because they fail to find the users for it. They maybe do the same thing as another service, but with better privacy, and it costs a bit more to use them. So people just don't care, and they use the public stuff where privacy is leaked. They just don't care. But still, we have to keep on trying. And my personal opinion is that it's half because it's too complicated to use and it's more costly. But the other side, the other half, is just because people are not used to having these kind of options. People are not used to having better privacy with their Instagram. And at some point, this will shift. It's either because governments will pressure to use better privacy, or then users will just pressure services that we need services with better privacy. But at some point, this will shift, and we will actually start caring more. So in conclusion, everyone should care about privacy. Everyone has something to hide. Everyone should be able to control what they share, how they share, with whom. But the problem is that adding privacy makes everything basically harder. Public blockchains are public. Just keep that always in mind when you use public blockchains. And the moment we start caring, we can actually start adding and using privacy in these services. Yeah, that's it for my presentation. You can scan my X Twitter here, and here's some cookies for you.
Yeah, thank you, Lauri. It was a great talk. Can we take some questions from the participants? Like, if you have time.
Sure.
Yeah, thank you. So, yeah, participants, like, if you have any questions, please let us know. Either you can type in the chat or you can unmute and you can ask yourself. Yes. Yes, sir.
Sir, as you were just talking about privacy and security, is it good like if we come with a thought of like cyber security or ethical hackers, and how bit are they differ and how the paths are go? Means if anyone want to enter, how should he or she do it?
So are you asking about public auditing and like ethical hackers, how they operate, and should you kind of do it, or?
Yeah, I mean it is actually related to privacy and security, like or not?
So this kind of public audits mean you have some public code that you want to get audited, and then there's this kind of competitions, like who finds the most bugs in this kind of code, and then they get some rewards for it. I think this is not directly related to privacy, but it's related to the security of all this project basis. So of course, it's a very good way to enter the space if you're interested in security, which also includes privacy. But I don't think these are directly privacy related things, unless the project is somehow like privacy related.
So I myself have a question actually, like as a researcher in cryptography and zero knowledge proofs, not zero knowledge proofs, like I used to follow the interactive proof systems like 4 or 5 years back. But the problem with zero knowledge proofs, which I identified, was like like in the last 3-4 years, you can see there are a lot of zero knowledge libraries coming up with a lot of different tech stacks. Right. Like, how do you cope up with all this information diverging like so drastically? Like, which one to choose? Like, if somebody starts fresh.
Okay, let's give a short history of zero knowledge proof. So it's actually something that started something like 40 years ago, and 10 years ago it started being feasible. So before that it was just a nice research, like in theoretical research, and 10 years ago it started being feasible to actually do this kind of zero knowledge proofs. And maybe 5 years ago the field started to be like ready enough that we started to have different languages, different libraries to write these kind of zero knowledge proofs. And after that, we've seen an explosion in the tech. So nowadays it's all sort of like new libraries and technologies are coming out all the time. And it's a nightmare to try to keep up with all of that. And it's kind of like, it's a positive nightmare. So you kind of have to choose your battles. Of course, nobody can understand all of that. So just choose what you're interested in. Some of the libraries and languages they're already like obsolete. They're already like shit. Just don't bother with them anymore. So you have to somehow kind of just either stick with one ecosystem, but that's one approach, or stick with one type of like zero knowledge proofs, like maybe Starks, Narcs, Plonks, whatever. Just choose your battles. You cannot know it all.
Yeah, well, maybe that's a great advice. Yeah, any other questions like from the participants? So we have one question in the
chat. If someone has created such an environment or community that truly provides privacy, then who are your primary target customers they will target in initial phase? It's an excellent question. If we knew, we would have a lot more privacy projects. I guess initially it's just those kind of fanboys. There's this kind of bubble in somewhere like in the X, like Twitter, people who are really interested in privacy, of course, like developers. So those are maybe even the first initial users. But then if you want to get some actual traction, that's the challenging part. Like, how do you get more than the 100 users who you have as your followers on X or whatever, who are the real privacy advocates? So how do you get the real users, like normal users? I think that's the challenging part. But the initial users, that's kind of easy. Like 5 friends, and those prefer 5 friends who are really into this thing. But after that, I guess it gets tricky. I don't have the answer. I wish I did. Can technologies like ring signatures or zero knowledge proofs fully counteract these de-anonymization risks? It depends how you use these, of course. Like whatever privacy technology you use, there's no silver bullet, so it depends. You can use whatever weird news, for example, zero knowledge proofs. You can use them to hide certain information, but then some other information may be leaked. Like maybe you hide this data, but then you still leak your IP, for example. So it depends on your goals, and there is no one right answer. There is no one right privacy technology that would fix everything. You have to. This is also like you have to choose your battles. Do you want to focus on like user data privacy, or do you want to focus on this or that? So you have to choose the right technologies for the right things. You're leaking something. It's almost impossible to create a perfect service, and using it would be probably horrible. Nobody would use it. So you have to choose kind of what you leak. How can systems using different privacy models interact securely and privately? Yeah, this is a good question also. Like there are some public blockchains being developed that have kind of both sides. They have the option to, when you are developing some program on this kind of like blockchain that enables like real privacy, you have this kind of options, like I have this data in my program. I have the option, do I make it private or public? And if it's public, everyone can just see it. And if it's private, I have to kind of somehow define who gets access to it and how. So, and then the real problem comes when you have to combine these, like, or transact between these two. So I have private data and I want to transact with some public data, and I somehow want to mix these, for example, like in an exchange. That's the horrible part. How do you make this so that the privacy is not leaking? And this is what, it's kind of like somewhat easy to make a privacy protocol, but if you want to have it interacting with some public parts, I think that's probably the worst part to implement in it. So that's a really hard challenge. Are there any open source projects you recommend contributing to? For learning real world blockchain privacy. Well, it's almost all of it is open source. Some of these projects are still closed source, but almost all of these, especially blockchain projects and Web3 projects, they are open source. So you can almost choose any one of them. For real world privacy, I was kind of like not directly referring, but if you're really interested in privacy and you want to try it out in the public blockchains, I recommend you check a project called Aztec. It's a layer 2 blockchain on top of Ethereum, and they have just launched their testnet, which they spent 7 years building it, and nobody else is doing it because it seems to take 7 years to build something like this. And now they finally launched the testnet. So if you want to try it, just go try it.
So how strong you feel like somebody need a strong mathematical foundations to understand the zero knowledge groups, or to build some privacy solutions? Like how good they should be in mathematics?
It's also a good question. They should be really bad in mathematics. Like the whole point of all these like different ZK languages and all sort of ZK libraries and all this stuff, it should abstract all of this complicated. Like there's horrible mathematics behind all this, but you should not care about it. That's the whole point why we create these weird ZK languages or libraries or whatever. The developers, they should know just the minimum amount of stuff so that they can develop private things. So if you have to start learning all the mathematics, then we have just failed miserably.
Yes. Now, why I ask this question is like many students that I see, like they start learning the zero knowledge groups and they will kind of go into depth. Right?
Yeah,
So sometimes like we need to pull them up, like try to build the applications around with the existing libraries. Then like once you understand, like then if you want something that you need to construct and that is not available in the library, then you go and you build your own modules. Like that's what we generally think.
Yeah, that's also the educational problem in this field. Like there is a lot of material, this kind of academic material especially. Like we have this wonderful new zero knowledge technology, and there's lots of academic text. Like there's initial paper about it, and then people write some blog posts about it. But that's so theoretical and mathematical. But that's what kind of like confuses people entering these kind of technologies. What we are missing a lot is this kind of really understandable things that don't go into the mathematics.
Yeah. So if we'll just take one question. Otherwise.
Yeah, there's more questions. What is the future of Bitcoin and crypto and quantum age? Quantum. I think my typical answer to this kind of quantum question is that the moment quantum computers start breaking some algorithms, we will have a lot bigger problems than just some stupid blockchains. Like all of your online banking and all the internet payment systems, they stop working. So at that point, I don't think anyone cares about blockchains anymore, if they're broken or not. So we shouldn't worry about too much about that. Even in public blockchain, there is also fear of losing data. And in private, there too, we have no chance. We lack trust. So how public is making over private? So of course, like if you are using public blockchains, you lose, well, I don't know if you call it losing, but you expose all of your data. So you don't lose the data, you still have the same data, but everyone else gets the same data. So there are possibilities to keep the data private. And of course, like all of this tech is new, some of this, it has a lot of bugs, and these projects also get hacked. So even if there is some privacy technology or some new privacy project, it may get hacked because the technology is so new and we may just lose trust in it. But we have to start somewhere, and maybe just don't put all your life savings in all this like weird new things quite yet. So this will take time before people start trusting these things properly, and that's totally fine and normal.
Yes, thank you. I don't think we have questions anymore, right? Yeah, back to you, Arham. You can have the concluding remarks.
Yeah. Thank you so much, Mr. Lauri, for enlightening and deeply inspiring keynote addresses. Your unwavering dedication to advancing privacy, security, and trust in the blockchain space, especially through your work in ZK and EVM development, truly resonates with your vision of more secure and decentralized future. We are truly grateful for the time you have taken to share your insights with us today, and we look forward to following your continued contribution to Web3 spaces.
Cool. Thanks a lot for the possibility. And just poke me somewhere if you have any questions.
Yeah, thank you, Laurie. Okay, once again, thank you
Okay,
from my side. As I have asked, like you agreed to come here and give a talk. Thank you very
sure.
much for your
Okay,
time. Yeah, thank you.
thanks. Bye.
Bye. Okay, participants. Okay, we'll end here.